The Big Bang is in a certain sense not singular at all. Now, conformal geometry is the geometry of angles.
Embark on an exploration of the universally accepted Big Bang theory, the captivating origin story that traces the genesis of our existence. Delve into the paradox of nothingness before the Big Bang, challenging the notion that something had to initiate this cosmic event. In today's video, we unravel the fundamental question: if the universe emerged from nothing, who or what could have created this concept of nothingness? Come along on an engaging expedition as we delve into the mysteries surrounding the origins of our cosmos, promising an enlightening journey. This is Reveal the Mystery. If you are curious to learn mysteries of the world, space, and beyond, consider subscribing. Scientists spent several additional years formulating a comprehensive explanation, culminating in the development of the Big Bang theory. Essentially, there was a void where neither time nor location had a presence, except for one anomaly: the cosmic singularity. This state of the universe was incredibly compact, dense, and intensely hot. Envision our entire cosmos condensed into a minute sphere, experiencing immense pressure and temperature. Ultimately, these intolerable conditions triggered the occurrence of the Big Bang. The Big Bang marked an explosive release of energy and matter, giving rise to everything observable today: time, space, and fundamental physical forces. Quarks, the minute particles constituting our world, dispersed within this intensely heated cosmic environment. As the universe cooled, gravity came into play, prompting quarks to attract each other. Subsequently, they aggregated into atoms, then molecules, eventually forming the earliest celestial bodies, such as stars. All of these transformative events unfolded approximately 12 to 14 billion years ago. Guth's discovery. Now that we have an understanding of the origin of our universe, the question arises: what existed before that moment? Alan Harvey Guth, an American theoretical physicist and cosmologist, has dedicated his entire life to unraveling this mystery. Upon delving into the Big Bang theory, Guth identified certain flaws, such as the surprisingly uniform distribution of matter, which contradicted expectations. To illustrate this anomaly, imagine suspending a paint-filled balloon from the ceiling and placing a white canvas on the floor below. If the balloon bursts and splatters paint, one would expect chaotic and uneven patterns. However, Guth argued that the early universe didn't resemble this randomness. Instead of envisioning a colored ball creating scattered spots, he proposed imagining a small red dot on the canvas, gradually expanding in all directions through successive frames, a depiction aligning with the evenness and proportionality observed in the early universe. Guth's groundbreaking theory, known as inflation, posits that before the Big Bang, there existed a force capable of providing a powerful acceleration, instantaneously and uniformly distributing everything in space. This idea has gained widespread acceptance among scientists, offering a satisfactory explanation for the universe's birth for many. However, not all scientists find Guth's theory sufficient. Martin Bogerwald, a German physics professor, presents an alternative perspective. Rejecting the notion that a cosmic singularity, an infinitely dense and superhot state, could spontaneously appear, Bogerwald questions its origin, challenging the conventional understanding of the universe's birth. Consider a pendulum on an antique clock, swinging back and forth in a continuous and seamless motion, representing our conventional perception of time as an uninterrupted flow. However, the concept of quantum time deviates from this familiar pattern. Imagine it as akin to the second hand of a clock, composed of distinct segments with brief pauses in between. Similar to the transitions between segments on a clock, the commencement of one quantum time segment marks the conclusion of another. To illustrate, let's revisit the analogy of balloons. According to the Big Bang theory, our universe began expanding, akin to a balloon inflating. However, this expansion is not perpetual. Eventually, the universe is predicted to contract, reverting to a state of cosmic singularity. In this cyclic process, the universe's expansion and contraction mirror the inflation and deflation of a balloon. Contrary to the idea of events emerging and vanishing spontaneously, Martin Bojewald's theory posits that each universe's origin corresponds to the end of its predecessor. Our universe is not the initial or final one. Countless similar universes existed before and will continue to exist. While this theory appears logical, it remains incomplete due to a lack of sufficient evidence. Presently, it stands as a hypothesis, awaiting further validation. Parallel universe. Certain individuals present even more unconventional ideas, and scientists advocate for theories so extraordinary that they transcend conventional imagination. Within this group of forward-thinking individuals are Vaughan Turek, a South African physicist, and his partner Paul Steinhardt, an American theoretical physicist. They explore realms far beyond the confines of our universe, suggesting that our current universe is not the first. Rather, an endless series of universes exists, characterized by an infinite sequence of significant cosmic events. Within this intricate cosmological framework, our universe represents merely one entity in an extensive array of parallel universes, all intricately woven into an everlasting cycle of renewal. This idea is simultaneously astonishing and unsettling, but how does it function? According to their theory, our universe is situated within what they term a brane, a membrane comparable to an elastic surface capable of contracting, stretching, oscillating, and undergoing various dynamic movements reminiscent of fabric on a rope. These parallel universes exist closely adjacent to one another, each with its adjoining universe. In this scenario, we are not an anomaly, but rather participants in this interlinked cosmic choreography. Brane Colossal. Another universe may exist just an inch away from ours, yet remains undetectable due to a minute space encompassing the fourth dimension. The initiation of these alternate universes occurs through a phenomenon termed brane collision, in which these cosmic structures gradually draw closer until a monumental collision takes place. This collision results in two simultaneous Big Bangs, giving rise to the formation of two parallel universes. Subsequently, these universes diverge, perpetuating their coexistence. The ongoing cosmic cycle involves the eventual fading away of these universes, followed by a renewed collision of the cosmic structures, leading to the emergence of a new universe. While this explanation may seem straightforward, it is grounded in the principles of string theory and M theory, which are fundamental to quantum mechanics. If substantiated, these theories could potentially clarify various aspects of our universe. Formulating such a theory is a complex process, and physicists like Turok and Steinhardt have engaged in extensive calculations, discarding numerous impractical theories. Additionally, grappling with the intricacies of thinking in 11 dimensions is an integral part of their work. Unfortunately, this bold and sophisticated idea has encountered skepticism and mockery. Turok and Steinhardt contend that scientists, like everyone else, are prone to the fear of change and the unknown. Challenging established beliefs is a formidable task, reminiscent of historical resistance to the concept of a round Earth or the initial rejection of the Big Bang theory. Despite challenges, Turok and Steinhardt remain steadfast in their pursuit, acknowledging that the existing evidence indicates the equal plausibility of each of the three theories they propose. Given the absence of conclusive evidence at this stage of human development, speculation remains the primary avenue. Yet, the anticipation endures that future discoveries may unravel the answers to the enduring mystery of the universe's origin, providing a definitive comprehension of our cosmic existence.